Hello everyone, welcome to my new video. And this is a new series which I am starting of C++ STL. This is the first and introductory part of what is a STL. We have to understand what is a STL, why do we need STL, and why only STL in C++, and many such things. So before starting with STL, the full form of STL here is Standard Template Library. This is the full form of STL. So yeah, let's see the introduction. What is STL? So before going towards STL, I want you to know that how a C++ program runs. So what do? We write a code, right? We write simply a code. We don't expect any, like, we just expect that it will produce a output, right? So we write a code to generate an output, and this will be here our code, the source code, right? Then we come to our compiler. What does our compiler does? Our compiler is doing the work of changing this source code, whatever source code which we write, okay, that thing it changes into a object code, okay, and .obj file. It creates a .obj file, and this is object code which the operating system has to work on it. Then by the use of a linker, that linker will link your object code to the executable code, okay. In the executable code, there comes in this object code. See, in this object code, it's just a form of your source code. It is just changed into a object code. Then into the object code, the linker, what it does is it makes it to a executable code where all the libraries, like suppose hashtag, the iostream file, and algorithms, header files, all the header files, okay, basically those things are caught here in the executable code, okay. So this is how a C++ program basically runs. Now let's see whether what is STL now. So why do we need STL and all? So basically, a standard template library is a set of C++ template classes to provide common programming data structures and functions such as lists, stacks, arrays, etc. Okay, now tell me one thing. We had a C language, right? We had C language. What was the need to create a new language C++? C. We had a C language. In our C language, suppose if you want to make a tree, or if you want to make a graph, or you want to make a stack or a cube, you need to write so long code for creating these things, right? You can't just create a stack in one line, how you do with STL. Same with Q also. So in C++ also, you have to make data structure in long lines. But after the introduction of this feature called STL, standard template library, these big data structures which needed to be declared in more than 10 lines, these things are now common program. Okay, these things are now common, uh, and they have been made as templates in the STL. Okay, so the common programming data structures such as the list, stack, arrays, etc. Okay, it is a library of container classes, algorithms, and iterators. Okay, just keep in mind container classes, algorithms, and iterators. Okay, there are four components in STL basically: algorithm, containers, functions, and iterators. Okay, yeah, the most important part out of these will be the containers and algorithms. There are certain algorithms, then iterator also. So yeah, let's see what is algorithms. The header algorithm defines a collection of function specially designed to be used on a range of element. Okay, they act on containers and provide means for various operation for the contents of the container. Okay, now tell me one thing. Suppose you have to sort a array. Suppose you have an array 10, 12, 13, 9. You have 2, you have 1. You want to sort this array by the usage of sorting algorithms. You have heap sort, quick sort, merge sort, insertion sort, bubble sort, bucket sort, so many sortings, right? If you want to do the sorting of this in one line, okay, if you want to sort it in one line, there is an STL which is in the algorithms header file. If I write include algorithms, okay, and I simply write sort ARR, comma ARR plus n, where n is the size and ARR is the name of this array. Okay, just this much if I write, it will sort this whole array in just this one line. Isn't it good enough to learn STL? Yeah, it is. If it is making our work so easier, then why not? So algorithms have been divided into three parts: so sorting, searching, and other algorithm for containers. Similarly, you have a algorithm for binary search also. If you would have worked on binary search, you will know that binary search algorithm typically takes around more than a whole while loop it takes. Okay, that big while loop which it takes. Huh? Instead of that, if you have just one line where you need to just write something, binary search, something like that, and inside the bracket you will put some you know things, and it will find the element which you want to find. Isn't it cool? Other algorithm for containers. So yeah, this was algorithms. In this part, we'll just see overview of what is there in C++ STL. Later on, we will try to find out that we will go deep into it. So in containers, store objects and data. Okay, container as name suggests that it is storing something. So it stores objects and data. There are in total seven standards. Okay, keep this in mind. Seven standards: first class container classes and three container adapter classes, and only seven header files that provide access to these containers or container adapters. Okay, so the types are sequence container. In the sequence container, you have implement data structure that can be accessed in a sequential manner, as the name suggests. So first is your sequential. Okay, in sequential you have vector, list, DQ, arrays, and forward list. Keep this in mind. Forward list is a new thing. It is not used widely for now. Just keep these four in mind. Vector will be of the most used. List also is not used much, but it is there. DQ is also used. Arrays, though everyone is using. Container adapters provides a different interface for sequential containers. Okay, just interface is different. Other things are same. You have queue in it. You have priority queue and stack. All these three are most important containers, right? Then you have associative container. This is very 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 useful and one of the most amazing STL. This thing, I would say, implemented sorted data structures that can be quickly searched, and it has a O log n time complexity. Okay, you have set, multi-set, map, and multi-map. I will tell you what is a set, what is a multi-set, what is a map, multi-map in later lectures when we will go deeply into associative container. Then you have unordered associative container. Just you will add unordered in front of these words. Okay, so you have implement unordered data structure that can be quickly searched. Okay, that can be quickly searched. Suppose if you want to search something quickly, you can use unordered associative container, and these all were introduced in C++11, but still it is used widely. Unordered set and unordered multimap are the most widely used. Sorry, map are the most widely used uh, unordered associative container, and they are of very good use. You have functions in STL. The STL includes classes that overload the function call operator. Instances of such classes are called function objects or functors. So this is a advanced concept, and very less people use these functions in C++ STL. Functors allow the working of the associative function to be customized with the help of parameters to be passed. Okay, so we will later on see in lectures what is this doing function. It is not important, but still we should see what is a function in C++. Iterators. So this is a important topic. I would say not much important, but it is important. As the name suggests, iterators are used to work on a sequence of values. Obviously, iterators is suggesting, the name only is suggesting that we have to work on some sequence. They are the major feature that allows generality in STL. Okay, you can access elements and I will show you by the use what are uh, this iterators. So let's see what are adaptive containers by the use of this map, this small flowchart. So is order import, suppose I talk about unordered containers. Okay, map key to a value. Suppose if you want to map a key, see, you have suppose a lock. Okay, you have lock 1. How can you open this lock? By the use of a key. Let's name that key as key 1. You have lock 2 and key 2. Can you open lock 1 with key 2? No. Similarly, can you open lock 2 with key 1? No. Just these two will be working. So this is a key, this is value, right? Our lock is here key, and our value is here this example key. Okay, so suppose if you want to map a key to a value, you have to use a unordered map. Okay, and suppose if you want to don't have to map any key to the value, so you use unordered set. Similarly, map key to value again. Suppose if you want to allow duplicates, do you want to allow duplicates? Yes or no? If no, use your unordered map and unordered set. If you want to allow duplicates, yes, just use this unordered multi-map and multi-set. And as I demonstrated here, yes or no. Similarly, here also it is working. Then we have is order important? If order is important, yes, then we have to go to see. As you know, all know, if you had have studied stack and queue, in a stack you can't take anything out from here. Whatever is entering here, okay, this is the first, this is second, this is three. You can't remove one from between. You have to first remove three, you have to secondly remove two, then you can remove one, right? So if order is important, then you have stack, queue, priority queue, last in first out. If you are using, then stack. If no, if you are using first in last out, queue. If that also you are not using, you use priority queue. Okay, so yeah, this is the adaptive containers. Good example. You can go through this. Map. This is very important. Good way of learning or remembering all your STL. So yeah, you can read this and you can get the things. Similarly here, that same thing, map set, multi maps, multi set, then array, then dq list, everything you can just go through it. In further lectures I will go deeply. We will see that what are STL. We will start with the first STL, that is we will be going through. Maybe we can start algorithms also, or we can start containers. That's totally on what is more important. I guess I will start with containers because that is more important for now. And so let's see in further lectures what are STL in more deep. This was just an introductory lecture that why STL is important, and that STL makes your works very easy, right? It makes your work very easy, right? And suppose if you don't have any time constraint or anything now, then so it is like a angel. So that's why go through, we will try to go deep into STL. Thanks for watching this video. Keep coding. Jai Hind.